Okay guys, so I'm just going to practice a few of these simplifying the indices, okay? So how you go about this, first of all you'd have your logbook out in front of you, right? And you'd open it up to page 21 and there's all your rules. And you just use these rules to see if you can simplify this. So basically, as I said, it's like a knot, okay? It's really messy. But if we can use these rules over here to simplify it out, then we'll make it less complicated, right? So I'm looking here at we have p squared on top and we have p to the power minus 1 on the bottom, okay? But we know that when we're dividing powers, we subtract the indices, okay? So I'll just do that over here. So I'd have my p squared, okay, that's that. And if I'm dividing these, then I subtract the power, so it'll be minus 1. So p squared minus 1 is the same as p squared plus 1. So p squared plus 1, which is 2 plus 1, which is p to the power 3. Okay, so on top we're going to have p to the power of 3 because we have p squared, and then we take away this, so p to the power of 2 minus p to the power minus 1. Okay, right, now we go to our q's. So again, we're dividing q's. We have q to the power 1 on top, we have q to the power 3 on the bottom, so we will go q to the power of 1 minus q to the power of 3. Okay, so we basically take away our indices, or our powers, sorry. So it'll be 1 minus 3, so p to the power 1 minus 3. Okay, that's the way I should really write it, which is, sorry, it's q to the power of 1 minus 3, which is minus 2. Okay, and there we go, these are gone. So there's our answer. Okay, if we look down here, straight away I see that I have these surds, these square roots. I don't like them, and they're making it a lot messy, so I want to change these square roots into indices, right? So I'll do that on the numerator and the denominator. Okay, so let's do the bottom first. So, well, this square root sign, if we change that square root sign into an indices, it's a half. Okay. We see that from, where is it now? Yeah, this row. Okay, so this would be x to the power of 3, but instead of having the square root sign, I'll have it to a half. Okay, and then this is x to the power of 7. Okay, now this is the fourth root, so that will be to the power of a quarter. Okay, alright, now I could say that this is x to the power of 7, and remember this is a power of a power, so I'll multiply them. Okay, so I could say 7 multiplied by a quarter is, oh god, it's 1.75, I think. Okay, but I'm not going to get into decimals. Yeah, I don't want it, it's too messy. So I can just say x to the power 7 over 4. That would be the same. Okay, x to the power 7 over 4 is 1.75 anyway. And likewise with this, I could say x to the power 1.5, but I'm just going to say x to the power 3 over 2, okay, which is 1.5 anyway. Lastly then, if I want to divide these, I'll just minus the powers. So it's x to the power 7 over 4 minus 3 over 2. And that's, I think anyway, x to the power of 1/4, is it? That would be 6/4. Yeah, 1/4, x to the power of 1/4. Okay, so from this mess, we get this. Okay, and I suppose if you wanted to write it another way, you could go cube root of x. Okay, so same thing. Alright. So we look at this, something similar now. we have these square root signs. We don't want them because they're messy. So anytime we see the square root sign, we will go x to the power of half plus x cubed, okay, but we're going to get rid of the square root sign, so it will be to the power of a half again, all over x to the power of a half, okay. Right, so I'm going to be dividing this into this and this into this, right, and we're seeing what I can do with it. First of all though, I'm just going to simplify out this first. So it's x to the power of a half plus, and on the bottom x to the power of a half, and here, so it'll be x cubed multiplied by a half, so 3 multiplied by half is 1.5, okay, say 1.5, or I can say 3 over 2, same thing. Okay, if we just come down here, so I'll write it out again, x to the power of a half plus x to the power of 3 halves over x to the power of a half. Now you're probably wondering, why do I have to divide this into this and this? Well, if I rewrite this, okay, I rewrite this as x to the power of a half over x to the power of a half plus x to the power of 3 halves over x to the power of a half. Well, that's the same as that. Okay, the only difference is I have it split up into 2, but it's the exact same. So let's take this bit first. Now again, you don't have to do that. Okay, I could just divide that into that and that into that. When I say divide, I mean take away the powers. Okay, that's how we divide in indices. So I'll do it here. So x to the power of a half divided by x to the power of a half. Now don't do this. Don't cancel them out. Okay, you can't do that with indices. X to the power of a half divided by x to the power of a half. Well, that would be x to the power of a half. And remember, when we're dividing indices, we take away the powers. So x to the power of a half minus a half. Well, half minus a half is 0. So it'll be x to the power of 0. So that's that bit done. And then this bit done, or this bit to do, we have x to the power of 3 halves. So x to the power of 3 halves. We're dividing, so we take away the powers. So it's x to the power of 3 halves minus a half. 3 halves minus a half is x to the power of 1. So x to the power of 1. And the very last thing, well, x to the power of 0, well, anything to the power of 0 is 1. And x to the power of 1 is just x. So there's our answer. Okay, so again, from this mess, we get this. And all that's not, that's not me knowing this off by heart. That's me, I suppose, well, I suppose at this stage I know them off by heart. But when you're doing them, you'll be referring back to these all the time. You'll be saying, well, what? Okay, look here, a to the power of minus p equals 1 over a to the power of p. So what I'm doing a lot of times is I'm using I'm using this one, aren't I? I'm seeing the square root sign and I'm making it back into an indices. Or often I see this, okay? I see it as a fraction, but I just change it to a minus. And I'm often using this one. And I'm often using this one as well. Look, the fraction with the dividing. Okay, when I divide two indices, I just take away the powers. Okay? Okay guys, so now we're going on to solving these these algebraic equations with indices. So here we have 25 to the power of x equals 125 over root 5. So I suppose we're kind of struggling where to start here, right? But look, straight away I'll know that if I could get this a bit simplified, it might be some point of start. So we've 25x equals 125 over 5 to the power of a half. Okay, now what I'd be thinking here is I'm looking to get these bases all the same. If these bases are all the same, I can do something with them. Can't do anything with this yet, okay? Because as I said, if you look in your logbooks, you know the way we were dividing indices, but the bases have to be the same. This base is not the same as this base. 125 is not the same as 5, and 25 is not the same as 5 or 125. So the bases are all different. So I want to get them to the same base. And you should realize at this stage that I can write 25 as 5 to the power of something. And I can also write 125 as 5 to the power of something. So I can get 25 and 125 written as a base of 5. Okay? Right, so here we go. I'm going to write 25. Well, 25 as a base of 5 is 5 squared. Okay? 5 squared multiplied by the x equals. Now, 125 is 5 cubed. That's all over 5 to the power of a half. Now I have them all as the same base. Okay, so now I can start doing things out. So 5 to the power of 2x equals. Now I'm dividing indices, so I subtract the powers. So it'll be 5 to the power of 3 minus a half. So 3 minus a half is well, we can just say. Sorry about that, guys. Phone call. Anyway, so we have 5 to the power of 3 divided by 5 to the power of a half. When we're dividing indices, we subtract the power, so we get 5 to the power of 2.5, okay, or 5 to the power of 5 over 2, whichever you want. Now I have my bases the same, I can forget about them. 2x equals 2.5. Do you know what? Just to make it a little bit nicer, I will say 5 over 2 to deal with fractions. And so a bit of algebra will give us x equals 5 over 2 divided by 2 is 5 over 4. Okay, so that's that done. Last one. Write square root of 32 as a power of 2 and hence solve this. Okay, let's do the first bit. Square root of 32 as a power of 2. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 then equals 32. Okay, but we're getting square root of it, so it'll be the square root of that. So the square root of 2 to the power of 5, well, remember from our rules, the square root, we can just change it to a half, so it's 2 to the power of 5 divided by half. Okay, and this is a power of a power, so 2 to the power of 5 by a half, or 2 to the power of 5 to the power of a half, it will be 2 to the power of, well, we multiply these two and you get 5 over 2 or 2.5. Okay, so that's that done. Now we're going to use that to solve this. Okay, so 16 to the power of x minus 1 equals 2. I'm just going to say multiply by, because that's what it is, yeah? The 2 is multiplying the square root of 32. So 2 multiplied by square root of 32. Now we already know what the square root of 32 is as a power of 2. It's that. So I'll rewrite that. It's 2 multiplied by 2 to the power of 5 over 2. I just want to change this to an indices. Okay, so 2, well, it's the same as 2 to the power of 1. We have 16 to the power of x minus 1 equals, now 2 to the power of 1 multiplied by 2 to the power of 5 over 2. Have a think now. We're multiplying indices. When we're multiplying indices, we add the powers. So that would be 2 to the power of 5 over 2 multiplied by 1. So that would be 2 to the power of 7 over 2. We want to solve this. The problem is we have different bases. Okay, so I need to write 16 as a power of 2. So 16 will be 2 to the power of, well, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, so 2 to the power of 4 is 16. Okay, and we have our x minus 1 already there. And that all equals 2 to the power of 7 over 2. Now my bases are the same. Okay, so forget about them. Now we have 4 multiplied by x minus 1 equals 7 over 2. Bit of algebra, I'll just simplify this first. 4x minus 4 equals 7 over 2. Okay. We will, I suppose, add 4 to both sides to get rid of that. So it's 4x equals 7 over 2 plus 4. 4 is the same as 8 over 2. Okay, just so I make it easier for myself to add. So 4x equals 15 over 2. Okay, getting a little bit, you know, this could potentially be messy with decimals, so I'm keeping it as a fraction for as long as I can. If I divide this by 4 to get x, I'll have to divide that by 4, which will give me by 4, 8. Okay. Again, now this you're thinking, where the hell did I get 8 from there? Okay, because when we're dividing a fraction by a whole number, we can just multiply the denominator by that number. Okay, so if you don't believe me, try it out in calculators. Okay, so therefore x is this. All right, so like this kind of stuff, it's not hard maths, right? It's not like it. I mean, the rules are in front of you. They're in your logbook, so you just need to get used to applying them. And yeah, you probably remember this is a knot, and you're trying to just, I suppose, untangle the knot to something, you know, to something handy that makes sense. I suppose when you're untangling a knot, you can try and you can fail, and you might end up making the knot even worse. But you have to go back again and try it a different way. Okay, but practice these. All right. We'll talk to you tomorrow. That's okay. Good luck.